Roughly 200 light-years away in the constellation Libra sits a faint subgiant star. Officially, it is HD 140283, but astronomers prefer a nickname that suits its reputation, Methuselah. In the year 2000, a team measured its age and hit a wall. According to the data, the star was 16 billion years old. This map shows the cosmic microwave background, the leftover heat from the Big Bang. It has loved the age of the universe at 13.8 billion years. The math created a direct contradiction. Methuselah appeared to be over 2 billion years older than the universe it resides in. It was older than the galaxies and older than time as we understood it. This was not a minor rounding error. A discrepancy of this scale suggested that the established models of cosmology were failing to account for something significant. Elements heavier than helium did not exist immediately after the Big Bang. They were forged over billions of years, generation by generation, inside the cores of stars. Methuselah is missing almost all of those elements. It contains only 1/250th of the iron found in our own sun. This low metal content serves as a chronological marker. It places the star's birth in the universe's earliest chapters, leaving its exact age as the problem that needed solving. To fix the math, astronomers first needed a more precise distance. They used the Hubble Space Telescope to measure the star's parallax, the tiny shift in its position as Earth orbits the Sun. They also rebuilt their evolution models from the ground up. They accounted for how helium settles toward the core and how specific trace elements like oxygen behave inside an ancient star. By 2013, the estimated age dropped to 14.46 billion years, with a margin of error of 800 million years. These new error bars finally, if barely, overlapped with the 13.8 billion year age of the universe. However, the answers continued to shift depending on the study. Traditional models required researchers to make assumptions about internal processes, such as how heat carries through gas, that they could not observe directly. The paradox was bounded, but it wasn't solved. The tools of the previous decade had reached their limits. Breaking through the ceiling of guesswork meant finding a way to probe the star's interior without relying on evolutionary assumptions. This is astroseismology. Sound waves bouncing inside the gas cause the surface to ring like a bell. The frequencies of these vibrations are a direct result of internal structure, providing a way to measure mass and radius without guessing the star's history. NASA's TESS mission provided the necessary data. TESS was built to find planets by watching stars dim, but that same precision allowed it to detect the microscopic pulsations on Methuselah's surface. In 2025, an astroseismic analysis gave astronomers a direct grip on the star. They calculated its mass at 0.75 solar masses, with an uncertainty of only 1%. With those constraints, the final age of the star was calculated, 14.2 billion years. Most importantly, the margin of error shrank to plus or minus 0.4 billion years. By listening to the star directly, astronomers removed the invisible assumptions that had pulled the numbers in different directions. They had an answer they could finally trust. The star is 14.2 billion years old. The universe is 13.8. Because of the tight uncertainty of 0.4 billion years, these two measurements now slot into one another without contradiction. The paradox is over. Methuselah is definitively younger than the universe by roughly 500 million years. The Big Bang model survived the test. Two independent methods, one using ancient light and the other using stellar sound waves, now tell the same story. This timeline places Methuselah's birth in the first 500 million years of existence, when the primordial fog was just clearing. Before Methuselah, there were massive stars that lived fast and died in titanic supernovae. Those explosions forged the very first traces of heavy elements. Methuselah formed directly from those ashes. It is a population 2 star, a witness to the environment that existed before the first galaxies had fully taken shape. By treating a universe-breaking paradox as a patient engineering problem, science has located a survivor from the earliest stages of the universe. To follow the detective work that continues to refine our picture of the cosmos, subscribe to the channel. We will be here to walk through the next mystery, one star at a time.